Alright guys, so I just got delivery of the battery cells from batteryhookup.com. I'm not sure about the tax and duty because I'm in Canada, so probably gotta pay a bunch of taxes, and I'll see what that's all about. But yeah, so I just got off the FedEx truck right now, which is pretty sweet. I thought I was gonna deliver a lot later. So yeah, I'm gonna open this for the first time. This box is really heavy. So I bought 60 cells of like the pouch cells, and I think 30 random cells that were super cheap. Yeah, these ones. So these are the cells. These are so cute. Oh my god. That is crazy how cute these are. Oh, they like clip together. Wow, that is awesome. These actually clip in together. I'm gonna come closer. Okay, so focus. So yeah, there's like a little thing here, a tab that like locks into the other one. So that's really cool how the battery like puts itself together with this casing. So that's pretty sweet. So we got tape on all the terminals, which is awesome. Okay, cool. Really excited about this. Okay, so this is how the cells came. This one has like a little bit of gunk on it, but it's like whatever. It seems fine. So cool. Let's just count these out, I guess. So I wanted to look at this and like see if that can fit onto a bike without being like stupidly big. So it's pretty nice. So that's the size of my hand. Next to it, let me use my foot. These are like size 11 or 10 and a half. So yeah, it's like pretty small. Yeah, I like it. Oh, and then it's got these holes that go all the way through. So if the battery clips aren't working, we can just use these mounting holes right there. Sweet. Yeah, this is gonna be really secure. All right, so we got all the batteries. I'm just going through the voltages of each battery. I just want to check if they're all like undamaged. So far these are all like 3.6 and 3.7. I have a small pack here. All right, all these are good so far. So I'm gonna check the rest of them, rest of the batteries, the voltmeter here. I am gonna start charging them because I already ordered a BMS from Battery Hookup. So that's coming in. I think it's coming next week. So I want to get all these charged up and then organize the pack. I think I'm gonna do 2 packs, and it's gonna be, two separate packs, but they're gonna be connected all together. And it's gonna be a 20S 3P battery pack. So I'm gonna have 20 of these batteries in series and then 3 in parallel. So I'm just gonna make some kind of metal bar and have some screws and bolts and nuts to put all these in parallel, and then wire these 3 packs in series. So 20 of these packs together in series, basically. So it should be roughly 2 kilowatts. It's going to be 84 volts fully charged at 24 amp hours. So it's like roughly 2 kilowatts. So it's like good enough for the e-bike. I might expand it later on, but it's honestly going to be hard to mount all these batteries to the bike. I think I might have to put like a back rack and a front rack and just put the batteries there, which is kind of a little iffy, but it's like whatever. So anyways, I got this charger, 10 energy, 100 watt. It's pretty cool. It's like touchscreen, so it's like the first time I've seen that. So it's pretty simple. Just go lithium ion. Maybe I should bring this closer because like it was actually pretty hard to set up at first because I kept getting an error. So yeah, you want to go 3.7 volts, 1S, right? So now I kept getting an error. So I put the capacity as 8,000 milliamp hours because that's what it is. And I put the charge current for 10 amps because you can charge these batteries at 80 amps, so 10 is fine. 4.2 is obviously the max voltage. And then here, the charge mode. I had this on balance and then I kept getting an error. You're supposed to go no balance since this is 1S, it's just one cell, right? So then you hold enter and it checks the battery before it starts charging, and then it gives you like a good to go sign. So what I'm gonna do, I'm gonna hook up the negative to the black, positive here to the red. Then I'm gonna hold enter. Okay, so it said, so it says here that it's good, right? So I just hold enter and it says bam, start, input's good. So I press start and then it starts charging. Right, pretty sweet. So I'm just gonna continue to check all these voltages and then hopefully I don't find any bad cells because I'm like right at 60 cells, so that's that. But yeah, I'll just like time lapse this. Okay guys, just a quick update. So I bought 4 more chargers. It was very needed. It turns out each battery takes like 60 minutes. It's like 50 minutes to like 65 minutes to charge. So it's very slow. So with only 1 charger, after like 2 days, I only did this small pile over there. So I have all these left to charge. So this is like the best way I found, just to do 5 at a time. What I'm doing right now is I'm adding this Captain tape. I think that's how you pronounce it. Whatever. I'm adding this Captain tape to these battery cells. This is the terminal, but apparently this tab here is conductive. So if you have the bolts on here, you don't want the bolts touching this because it'll short to this part of the battery cell. So I'm putting Captain tape like this, where it covers over the tab and the terminal, and the bolt can just have conductivity through just the terminal by itself. So I'm doing that right now. It's a very tedious process, but I have time. All right, so I totally forgot to mention, guys, what I did after charging the batteries was I realized I had to do a capacity test for each cell to organize the cells properly. So I had to recharge everything again. I wasted a lot of time, so learn from my mistakes. What you need to do is charge the battery fully and then right after do a discharge on the battery to get the capacity. So I can show you that really quick. Alright guys, so with this thing here, what you want to do is charge first, and then here you want to set your parameters. So it's a 3.7 volt nominal. Oh shoot, let me fix the focus. Let's do that, okay. 8,000 milliamp capacity because these are 8 amp hour cells. Charge current for 10 amps because we can handle that. And the end voltage is going to be 4.2. And then you have to make sure you set this down here to no balance instead of balance because you would get an error if you did that. So it's no balance because we are going directly to 1 battery. Whoops, let me get these here. We're using these, right? And we're hooking them up directly to 1 battery. So that's why we're doing a no balance. Okay, so what you do is you hold enter, it checks the battery, then you start charging, right? So after you do that, after you charge, you have to go to discharge. So discharge, it's very similar, same thing, 3.7 volts, 8,000 milliamp hours. The current has a maximum of 5, right? See how you can change it? It's a max of 5 for discharging. And then it only goes down to 3 volts, not 2.8, which is like the recommended discharge voltage for these lithium ion cells, right? So it's the same thing. You hold enter, it checks the battery, and then it discharges all the way to 3 volts, and then it gives you a milliamp hour reading at the end of the discharge cycle. So from that, what I learned is some of the cells don't show the full 8,000 milliamp hours. Like I think the lowest was like 5,500 milliamp hours, and so that's because I'm sure when Battery Hookup does their testing, they go to 2.8 volts. This discharger slash charging device only does 3 volts, so it's not going to show us the full capacity of these cells, which is like not too bad. So it ranges from like 8,000, I think the highest is 8,500 and the lowest is 5,500 milliamp hours. But the average is probably like 7,000 milliamp hours. So I can show you what I have here. The pack is finally done. Okay, so these are all fully charged. It's a big fat stack. I can show you some capacity. So we have 7,500. Is that? Can you see that? Yeah. 7,500, 7,600, 6,000, 7,400, 7,700, 6,600, 7,900, 7,400. You get the point. It's a nice average around 7,000 something milliamp hours. So we got the nice 2 fat stacks fully charged, and we got the discharge capacity on it. We're good to go. So what I'm doing now is still waiting for the BMS to show up. Once the BMS comes in, we can start putting this pack together. Okay guys, we got the BMS, came in from battery hookup. So what I'm gonna do is put together the pack right now, like the final assembly. So I have to organize the battery pack in regards to the capacity. So I'm going from least to greatest, and then I'm gonna bring those modules together in pairs of 3. So yeah, that's what we're doing now. Alright guys, so we're going from, what does that say there, 8559, or sorry, geez, 5591. Okay, 5960, we're in the 6,000s, 63, 64, 66, 68, 69, 7, 71,000, or 7,100, sorry, 7,100. 7,100, 72, 73, 74, 75, 75, lots of 7,500, 76, 77, right? Focus, 77, okay, then we go back, 78, keep going, 78, 79, and then we jump to 82, 83, 85, and the highest is 8594. So now what I'm going to do is put these together from that end to this end. So these are the 20 packs of 3 cells in parallel. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 packs of 3P. And that's my food. So what we're going to do, we have the positive here, we're going to rotate this, so make it positive to negative. And I believe I have to flip this as well. And it's nice, the cases have yellow paint where the positive is, so you can see how it goes positive to positive, and then off to the next negative. So what I spent all night doing was making these aluminum bars. Let me see if I can get closer here. So I bought these 516 by 516 aluminum bars. They're very light. I drilled, what size was this? 532 holes in here. And then I got these 2-inch. Oh, can you focus? Yep. 2-inch 632 bolts and nuts, as well as washers. So I'm going to use these to connect the terminals instead of spot welding or like ripping. I'm so sweaty. So I think what I'll do is try to do this pack first. Okay guys, so just a quick overview on how I made these aluminum bars.
Very tedious work here. So basically I had like really long bars. I think they were 6 foot long. I ordered online and used a grinder to cut them. And for some reason I wanted to do this in my dress shoes. Got extremely dirty and yeah, just drilled 2 holes for each of these aluminum bars. A lot of work, but totally worth it in the end.
With this feeling I can leave. I'm working and I'm dreaming. Will you dare to give it all?
Okay, so we got 1 pack done. This is like half the pack. I think I'm gonna do 2 separate modules on the bike. Alright, it's not too heavy. So we have 1, 2, 3 like this. Okay, so this is 1. So we're gonna count the series. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 in series. So we pull up the calculator. So 10 in series, and the voltage should be 4.12. So we should have 41 point something volts. Okay. Get the voltmeter. This is our negative, this is our positive, and look at that, 41.2 volts. That is awesome. We did it. So, here is the BMS. Alright, BMS is here. This BMS came with no instruction manual, which was really shitty. I did buy the Bluetooth module, so that's there. But it's like, at least include like an instruction manual or like a wiring layout. Like, come on guys, that'd be nice. So anyways, we got the B minus here. Probably gonna put these together on a nice big terminal, and then this is the C minus. Alright guys, we got both battery packs done. Okay, so we have all these aluminum tabs in between all the cells with bolts and nuts. So right now what I'm gonna do is set up the battery management system balance leads. So these balance leads go from BC0 all the way to BC20 because we have 20 cells in series. So we determined we flip it up here. This is the most negative of the battery pack. So it's gonna go negative to positive here, to negative to positive over here. And this other part of the battery pack, the second battery pack, this is the most positive. Alright, so we'll deal with that one later. So first we're gonna put together just this battery pack. Okay, this is the motor. That's the controller, the big emergency stop. It's got like a twist throttle. This is one battery pack and the other one is there. And that's the battery management system. This is basically everything except the bike. Okay guys, we are taping up the last battery. The other batteries over there all taped up. Now I'm doing the last terminals here. This feels so good to be finally done. Alright guys, so we hooked everything up. We have the battery pack connected to the BMS. I actually had the wiring wrong for the BMS. Not with the balance leads, but with the output. So I realized the negative of the battery goes through the BMS and connects to the negative load. Okay, and then the positive end of the battery goes directly to the load. So the BMS does not shoot out the positive power, it's all negative. So it controls it that way. So I have the motor hooked up to the controller. Got the 3 phases here. So as you can see, 82.4, give it a spin. And then the BMS app is working as well. So it's gonna tell us how much current we're pulling. So this is 1 amp, 1.2, 2.6, 4. I'm like barely touching this though. That's like not anywhere. That's like maybe like a quarter pull. I'm so scared to push this. It's got so much torque. Like it lifts itself and it's heavy. 6.7 amps. So we did it. We got it to work. So I got this this tiny 84 volt 3 amp charger. Okay. I checked the voltage of the output here. It's 84.2, which is close enough. So this one goes in the positive. All right. I'm gonna hook that up right now. So let's go to the dashboard here just to see if it starts charging or not, all right? So this goes to the positive. Whoops, that was crazy. Okay, that's pretty tight on there. Now this battery has to come here. This battery negative. So let's actually let's unplug the charger. So charger's unplugged. LED lights are still on. Yep, they just shut off. Okay. So I think I brought a bolt here. Here it is. A bolt, a nut. I'm gonna put these two together. Okay. So from the diagram, the charger goes straight to the battery plus, and the battery negative comes from the BMS. Right? So the battery negative is going through the BMS. That's the whole purpose of the BMS. So we'll put this on. This might spark. Okay. The spark always makes me nervous. Hate that spark. It's like, is something wrong? Okay, so spin this nut. Oh, no, don't fall, please. Please don't fall. This is the longest bolt ever I could find. I picked the longest one. Okay, so that's tight on there. Crank it. Alright, so it's cranked. That's good. Let's connect it. Now we're gonna plug in the charger and see what happens. Please don't blow up. Please. That's correct, right? Positive, negative. So the battery or the charger starts running. It started running already. So if we look here, this is hard to do with one hand. We have 2 red lights. That was green before, now it's red. And the fan turned on, so it means it's charging. And then the best part about it is if we look at the BMS dashboard focus, it says 3 amps charging, which is what that charger is rated for. So we have 250 watts, or sorry, 243. So let's check that. If we go 84 times 3 amps, there you go, 252, that's the correct wattage. So this is working perfectly. That's awesome. So I'm gonna charge all of this. So all these, oh, it says balancing. There's B symbols. So that's cool. I'm gonna let this charge and clean up this humongous mess I have here. All right, see ya.
Okay guys, so at this point I took the bicycle to a mechanic shop. All right, so we mounted the controller in the center there, and next we mounted the motor with the bottom bracket of the bike, so it just slides in the original pedal crank. And then as you can see at the top left, we added a rear bracket for the batteries to mount on. All right, and here's a picture of the battery, the 2 battery packs in 2 separate boxes. So these are car battery boxes from Amazon that we purchased. So that would hold both batteries. So here's the bike in a prototype stage. It's all put together. So like I said, controller in the middle, the 2 batteries at the back. Now, having the batteries at the back was an issue. So with this setup, all the weight of the entire bike is very high and it's at the back. So the majority of the weight is the batteries. This is 2 kilowatt hours of batteries. So it's a lot of range, it's a lot of power, but for this bike, it's way too heavy. So here's another picture of it from the back. Yeah, as you can see here, it's just pretty unstable. The kickstand couldn't even hold all the weight. And yeah, so what would happen is when you would go at a decent speed, the entire bike would shake and it was very easy to tip over. So just overall, just very unsafe. And what happens next is very sad. So just take a look at this video. Oh, I'm coming in all happy. Look at him on his e-bike all happy. All of a sudden, destroyed. And I just stare at it. Okay guys, so what happened here in this very sad video? So this is after me working on the bike for, over a month, and I was testing the bike in its prototype stage, going for a ride out in the parking lot, and then everything was going good. It actually started to rain, so I was like, oh, let me bring in the bike, to keep it safe and be smart. So I was pulling the bike, and as I was getting off, I did not turn the key switch off. And I have no experience driving motorcycles or mopeds or anything before. So this is my first time experiencing a twist throttle. All right, so that's the throttle for the entire bike. It's a twist handle. So as I'm getting off the bike, I actually twist the throttle. So like at this point, the bike is going full throttle and I just lose control of it because I have no idea what's going on, and it happens so fast. And then I crashed the entire thing into this cart, this metal cart, and the battery falls apart. It's just like all mangled up. And then I just stare at it sadly in disbelief. All right, so after that tragic incident, I had to basically redesign the entire bike. So from what you can see here, this was my next prototype. So I greatly reduced the battery pack size. In this setup, I only used 20 battery cells. So this was 84 volts at 8 amp hours roughly for each cell. So with this setup, I actually got very low range, but the overall riding capability of this bike was a lot better and much easier to control. But yeah, like I said, the range was very bad because the battery pack was just so small. And then I also think I had some bad battery cells in this setup. So I did switch these out for some better cells. And then I moved on to this setup, which is basically it's a whole nother battery pack placed in between the frame, like the center frame. So in total in this setup, I have 40 battery cells. So there's 20 going up, and then there's 20 going sideways or horizontally. And with this setup, I had 84 volts at roughly 16 amp hours. So this is a 1.3 kilowatt hour battery. So with this, I got decent range, and currently this is my current setup. I'm getting around 20 kilometers range, and that's like me going full throttle. So yeah, this setup ended up being a lot better. This is what I currently use. And yeah, it's more rideable. All the weight is in the center of the bike. It's a little bit lower than having it in the two back racks, and it's just a lot easier to control.
So right now I got this thing charging. So I bought so this is supposed to be a 12 amp charger. So as you can see here, we have 12 amps. What's that 20? I'm not sure what that 20 is, but 12 amps at 84 volts. And then this is pretty neat. It's got like a dial where you can bring it down in current, like a current dial, and bring it right back up. And then I just added these markings here because nothing was in English. And yeah, you can power on and off, and then also like a voltage and amperage. So right now it's at 81 volts, so it's getting closer to the complete 84 volts. So that's the charger. Now the thing with that is it doesn't really do 12 amps. It only does 9.6. I think the most I've seen is like 10, but it's like whatever. It's alright. Anyway, so that's just the charger. So now for the bike itself. So I guess we can start with the motor. So this is from Clyclone, and let me get it right in there. It's supposed to be an 18,000 watt brushless DC motor, right? It's rated for 72 volts up to 108 volts. And 6,300 max RPM. So I bought the 18 kilowatt kit from Clyclone. I'll put the link or like a picture here or something. So yeah, I bought the 18 kilowatt one. It was the most expensive one, but it turns out it's not 18 kilowatts. It's not anything close to that. So the most I ever pulled from the controller is 77 amps, and it's supposed to do 150 amps. So at 77 amps and 80 volts, which is what what the battery pack is usually at when you're pulling 77 amps, that's only like 6 kilowatts. So I basically got ripped off pretty hard. So yeah, don't buy from Clyclone. It was expensive. The quality of the materials, like, yeah, I'll show you on the other side. The gearing is not good. Like, the quality is just terrible. Yeah, and it came with this controller that has no markings on it. I'm just supposed to trust that it can do 150 amps, but it doesn't. The max I got, like I said, was 77 amps. So it's like not even half of what was like promised. So don't buy from Clyclone. They're very shitty. Not trustworthy. I was emailing them back and forth, like telling them, hey, I'm only getting like 77 amps, like what's going on with this controller? They would not reply to me. Like, I messaged them, emailed them a bunch of times, and then they only replied to me once I filed a claim with a dispute with my credit card company. Then all of a sudden, like right away, they start answering. So they're a very sketchy company. It's all the way in Taiwan. Like, there's nothing you can really do about it. So don't even buy from them. There's there's a lot more other better sources to buy these parts from. Anyways, so that's my ramble. Like, the bike is still good. It's just like not as expected. Like, I was expecting like at least 120 amps that I would be like shooting into this motor or pulling from the batteries, because I got promised 150, but I'm only getting 77. Like, it's still fun, it's still fast, it's just like kind of disappointing. So let me give you a quick little tour. Or actually, sorry, let me show you the crappy gearing I was talking about. So this was the motor sprocket I got from Cyclone. It fell apart, I had to weld it. Very shitty. This is the crank pedal. This thing literally wobbles. Like if you look at it, see how it's wobbling? Like, it doesn't do anything and it's not even straight. I'm not sure if you can see that on the camera. Let me see if I can focus that. Basically, when you're riding, it wobbles like this. And then at high speed, that's obviously not good to have when you're wobbling. So I had to put this custom little tensioner. The one that came with the Cyclone motor is just trash. Even though this looks like absolute garbage, this is still better than the one that came with the Cyclone motor. So I'm still gonna upgrade this. I'm just waiting for some parts from Amazon. So yeah, the thing is, right now I have it set up on this 9-speed. However, due to the fact that the front pedal wobbles so much, I can't really use these other speeds. Like, I can use them, but at like high speeds they skip, and then I can like break this chain because from all the skipping. So I just leave it on the second gear here. So I like the second gear, it's got good takeoff, and then it still has good high speed, so I don't really change it. So yeah, like I said, the controller's here. It came with all these extra wires for like brake and reverse and different things. So there's a lot of stuff I'm not using. I just tape it down. It's pretty simple. So yeah, I added this little back rack here just for the controller. It's all right. It's from Amazon. This will be in the description below as well. Yeah, so all the parts you see here will be in the description below. So now the only thing that is awesome on this bike that I bought is the batteries. So I got these batteries from Battery Hookup. They are pouch cells. You can't really see it, I got it taped with this ugly tape. But anyways, so yeah, pouch cells. And then I got their BMS that is on their website as well. So this is a 20S 2P configuration. So we have 20 cells in series and 2 in parallel. And yeah, it's up to 84 volts fully charged. And then the thing that's awesome about the BMS is like the BMS will actually stop charging if it's too cold. And like you can set the parameters on the phone app, which I'll show you soon. It's really cool. And if it's too cold, it won't discharge the batteries because that's bad for the chemistry. And yeah, it's just the BMS is just awesome. You can set all the parameters. What else? So yeah, the batteries are a little bit heavy, and like with this bike frame, it's really hard to get this set up. Like, so I have a pack here and then a pack there. And it is a little bit on the heavy side, but it's like, it's all doable. It's really good. So now I'll show you the app. So this app is honestly so amazing. So you get speed up here. This is your temperature, an estimated kilometer range, which is not accurate. And then it shows you the current meter here. So right now, it's positive current right now because we're charging at 9.6 amps. So you got 9.6 amps coming into the battery charging. What else we got here? So if I go up like this, you can see each series of cells. We have 20 cells here, right? Pretty sweet. So if I focus on this, you get the voltage. 1 second. Okay, maybe that will focus better. Okay, you get the voltage of each one. And then it shows a B for like balancing. Come on, focus. Anyways, that's what it shows. So yeah, that's really handy. If I go back to the dashboard, you get this stuff here, and then it gives you a score on like how close your voltage is from each battery cell. So it says there's a difference of 0.041 volts between each cell, so that's pretty cool. So now you can go to your parameter settings, Now these are awesome. This is where you can set like your over voltage protection, under voltage protection. And then, so yeah, I've done this, I've tested this, and I set the under voltage protection to 2.8. You can see there, 2.8. This lens is not good for focusing close up, sorry. There you go, 2.8. So anyways, yeah, I've done a range test on this, and I was biking, or sorry, not biking, I was riding for like 46 minutes, and I got up to 17.78 kilometers on like a GPS tracking app. And then the entire system shut off because this one cell up here dropped below 2.8, just the first one, even though all these cells were like 3.5, 3.4, 3.6, so I still had more juice in the battery pack. It's just that one cell shut off the entire system because the BMS shut it off. So it's a good safety feature. I do have to figure out that number one cell. It's just, this might be a pain to take apart, or like I might be too lazy, I don't know. So like I got 17.7 something, 78 kilometers of riding, which is still good. It was like 46 minutes of riding, and that was like me like doing full throttle and a lot of braking. That's another thing. This bike is pretty heavy, so the brakes, like I have these disc brakes there. I do need to tighten them, I feel like they're not grabbing as quickly as I need to. But yeah, the bike is pretty powerful and heavy. So I just have a shitty bike lock. I got the key ignition here. So this is a simple like, switch. It goes in, now it's on. I put this flashlight on here for when I go at night. And then, oh yeah, I have a thumb throttle. Let me shut this off. Or let me take the key out before I do this. And this is the thumb throttle. I did have a twist throttle before, but the twist is very dangerous if you're not an avid rider, like I am not. So yeah, that's the whole bike right now. It's pretty fun. Like I said, I would not go with Clyclone again. They are very sketchy, and yeah, their website is just like all lies. Like this is not a 150 amp controller. It's just terrible. But other than that, the batteries from Battery Hookup are awesome, very powerful. The BMS is so cool. Like I just ride with this BMS, or sorry, with this page open, and I just see the batteries as I ride, so it's really awesome. And yeah, that is pretty much it. All right, boys, let me show you how much power we are cooking with here. So it finished charging. This is gonna be a little scary. All right, but here we go. So I'm turning the power on with the key and give it a little throttle input. So yeah, very powerful. That wasn't even full throttle. It's too scary to go full throttle like this. But let's do it. All right, full throttle, here we go. So you hold it from here. Alright guys, see you later. Look what we have here, guys. This is an e-bike update. Okay guys, we got an e-bike update. This is obviously not the right environment for my e-bike, but a lot has happened. So let me just show you what we got here. What they did to them. Alright, so one big update is I added this tensioner here. So before I had a really shitty one. See, this is much more proper. You see that? Oh jeez. Got still this chain up here. Yeah, that's another problem I gotta talk about later. I'm full of surprises here. Anyways, so this works perfectly, right? So the issue was with this setup, generating a lot of power. I had this on like I think gear number 8. All right, 8 or 7 on my 9-speed. Let me still have it here. Oh, here it is. Hiding. Oh, we got a Christmas special. Christmas special guest right here. Okay, so I was using this cassette, right? And I think I was using gear number 8, right? On this is a 9-speed. So what was happening was this was generating way too much torque than what this is rated for. And I actually broke the spokes off this wheel, this 29-inch wheel. So it was too much power for these spokes to handle, because these are cheap spokes. These are like the standard ones that come with mountain bikes from retail stores, so it's very cheap. These broke, and this cassette like bent. So when you spin this cassette, I don't know if you can see that, but it's like off, right? So I can't use this anymore because these bend way too easily. And the main problem was I'm using a high, like the high torque gears, right? Oh, sorry, this is not gear 7, this is gear 2. That's what I was using, gear 2. 2 or 3, my bad. So I was using gear 2 or 3 on this setup, or sorry, this setup. Broke the spokes because there was too much torque for this wheel, and the cassette rings bent, like these bent. Like I re-bent them, and they're still not straight, right? So the problem was, when I was using, alright, so let me give you a visualization here. So I'm on number 2 here for the speed, for this crank. The motor uses the largest one to get the most torque, and the gear set uses this crank, speed 2, right? So what was happening was, I was using gear number 2, right? So I had this big angle, this sharp angle, and there's no need for switching gears with this setup, because this is 6,000 watts of output power, not just theoretical, it's like the raw output power of this. So you don't need like any gears to be switching. You can get like at really high speeds with just a fixed speed number 2, or sorry, just fixed gear using the second gear, right? So the problem that was happening is this angle was too hard. So on takeoffs, it was yanking this wheel, or sorry, the other wheel, and the spokes couldn't handle the torque. And then on top of that, there was an angle, right? So all the torque is being yanked on the cassette. So it bent the cassette and broke the spokes, and it's completely messed up, right? So I went to a bike shop. I went to Bicycle World in Windsor. I talked to, I think it's the owner, his name is Rob. This guy is like very knowledgeable on bicycles. Gave me the complete rundown of this project and all the problems with it. He basically said, like, long story short, too long didn't read, these bikes are built for human output power, and the average human makes about like 300 watts, and then like professional athletes, I think they can make up to like 800 watts of like leg power, right? So these are built for human power. So a range from 300 watts to 800 watts, like max, and that's like for expensive, high quality bikes. All right, this is just a retail bike here. This motor from clyclone-tw, don't buy from them, they're very sketchy. This is supposed to be an 18,000 watt motor, and I'm only really, or sorry, like a kit, 18,000 watt kit with this controller. It's supposed to shoot out 150 amps, but meanwhile it's only shooting out like 77, like max. So this is only really generating 6,000 watts. However, 6,000 watts of raw power is way more than what this bike was intended for. So that's why at high speeds this thing wobbles, and at low speeds the torque breaks spokes and breaks the cassette. So now my solution for this is going to be getting a single speed conversion for this hub here. right? I bought one off Amazon. I'll put the links in the description. I'll maybe show a picture here, wherever my head is. I don't know where my head is at. So yeah, I'm gonna get a single speed. So I believe it's a 25 tooth, or the one I'm getting is a 23 tooth, and then I ordered an extra 25 tooth that might take a little bit longer to get in. So I'm hoping having one single speed fixed gear, which will bring the single cog out here. It'll make it more straight in a line, so there's no like angle torque tension. Like it won't be yanking on the gear. It'll just be straight and aligned with the crank, right? So with that, I won't get like the good like high torque acceleration with a single cog that only has like 23 to 25 teeth. The cassette gear I was using, number 2, I think it had like 34 teeth, so it was a really good acceleration. And so it was a larger gear at the back, so that means more torque, and that's probably why I broke the spokes. So I'm going to settle with the 23 tooth single speed cog, or the 25 tooth, whichever one works better. So I have that coming in. It should come in, I think, next week or so. And yeah, so that's the update. The battery pack is still good. Obviously I can't use it right now. The good thing about this BMS is it shuts down charging and discharging at these cold temperatures. So the bike is like inoperable right now. But other than that, things are great. So yeah, this is what I want right here, right? This nice, smooth, straight drive chain with the drivetrain with this chain link here, nice and straight. Before, what I had was this. It was at an angle, so a lot of tension and a lot of like messed up things were happening. So this is what I want, nice and straight, right? Nice and smooth. So I'm gonna be doing that. Let me give you the view from over here. So this is what I want to have. So before I was like this, at an angle. This is what I want, nice and straight. Alright, so the motor is going to be spinning this gear. Alright, it's going to be spinning this way, but I can't turn the shaft right now. So it's going to be like that. I'm going to have that output. So now, the other thing I changed. Alright, so I found this, let me tighten this grip here. So I found this wheel, right, off Kijiji. That's like Canada's Craigslist. So I took that to the bike shop, and Bicycle World said this wheel is a lot more higher quality than the other wheel I had, and he said these spokes are stronger too. So there's actually more spokes in this wheel. There's stronger spokes. And on top of that, the wheel diameter is 26 inches. So before I had 29 inches. So when you have that much torque over like a long spoke, it's going to break easily. But if your spoke is smaller and stronger, in this case, it's going to hold up to the extra torque. So this wheel should work. I'm also getting a tire from Bicycle World and then a tube to fit this 26-inch wheel. So it might look a little bit funny, like overall, when this is done, because my front wheel is 29-inch and this is a 26-inch, right? So it is going to look a little bit funny, but that is the way it has to be to handle this 6,000 watts of power. So learn from my mistakes. Don't go for this crazy high output power. This was expensive. It wasn't as what was advertised. It was supposed to be advertised for 18,000 watts. It's only 6,000 watts. Still, 6,000 watts is kind of overkill for the mechanics of the bike and what these frames and like the whole purpose of these bikes are not made for 6,000 watts. It probably would have been better to stick with like a maximum of 3,000 watts, like 3,000 watts peak. I still do like the mid-drive configuration. I kind of dislike the hub, the in-wheel hub motors. But then again, if I would have done like a front and rear hub motor, that probably would have been a lot better than this setup. And so yeah, just learn from my mistakes. I could have probably kept the original crank and cassette with a hub motor, and a hub motor here as well, and could have stuck with the same 29-inch wheel. So yeah, that's the update. Parts should be coming next week. Gonna throw it all together and then test it out. Hopefully this wheel can handle the torque still, and hopefully the single speed cog conversion kit that I'm getting from Amazon can hold up to the 6,000 watts of power. Hopefully it doesn't like come apart and bend easily like the cassettes did. So yeah, stay tuned for the update, and hopefully it stops snowing too, so I can actually ride this, because I can't ride it right now. But yeah, that's pretty much it. All right guys, take care. Okay guys, time for another update with the bike. We got the single cog conversion kit. All right, so it comes with the cog itself, a locking nut, and then these spacers to put on your free hub assembly, which I'll show right here. All right, so this is the free hub. So this simply goes over this, and I also got this tensioner here for the chain. So we're gonna put it all together now and see how it works. Okay, so that's what we got right now. Okay, let's try to power this up. Okay, here's the test. So I kind of need somewhere to put this. I think we can just get rid of this actually. Alright, time to test it full throttle. Here we go. Okay, time to ride it. Okay, you can sort of tell that the rim is smaller on the back. I'll bring it this way. Okay. So yeah, it's like a little bit smaller. You can definitely tell. Luckily the pedals don't come near the ground. So that's good. Just gonna try to ride it really quick. Just the pedals though, no power. Alright, so I removed the back derailleur. I have the fixed single cog. Alright, I got the tensioner in. I had to adjust it downward to have more tension because it did slip off earlier, so I fixed that now. The chain is pretty tight, so it still bends a little bit, but more secure now. The overall chain is aligned to the pedal crank, which is good. So this chain is tight, the motor chain is tight with this added tensioner. That's working perfect. So I did a quick test. The batteries, I haven't charged these in like 2 weeks and they're still holding their charge, and I just did like a nice quick run. So these batteries are awesome. Battery management system is awesome from battery hookup. I'm turn the key off. So yeah, thumb switch, thumb throttle, key switch, the phone hookup, and then I got this. This converts Ooh, let me open this up. I'm trying to do this one-handed. Yikes, the struggle. So yeah, this converts the 80 volts DC from the battery pack to 5 volts for this USB charger to charge my phone. So it says on the back here, 5 volts and 2 amps. So it works from 36 volts to 100 volts DC. So that's good. So I gotta hook that up. I'll probably do that tomorrow. I gotta figure out where it's gonna hook up though. I need the positive and the negative of the battery pack, so that might be a little hard. But we'll see. Maybe I'll just run it to jump in here. Nope, in there, yeah. But yeah, that's awesome. So it's finally good. So obviously the acceleration's not the greatest because this is only a 23 tooth sprocket. I did buy a 25 tooth and that's going to be coming in. So yeah, that is that. The 25 tooth is coming in. It might be a little bit more acceleration, but it's not going to be that much of a difference. This just has really good high speed. So yeah, it's awesome. Finally coming together. Sweet, guys. I'm super tired, as you can see, and yeah, that's it for now. Peace. Now we're just gonna do a quick test. Just revving the engine, or sorry, revving the motor. I did a quick run, about 10 minutes of riding, and this works perfectly. So yeah, now we're just gonna do a full throttle test. Okay, so keys on. We're gonna lift it from this part here and just go. What does that sound? Okay, there's a sound coming out from somewhere. Oh. It's the tire. Okay, well, I'm gonna figure this out.
Alright guys, so as it turns out, you're actually not supposed to be spinning a bike tire extremely fast and then hitting the brakes. So basically inside the bicycle tire is a separate tube, and when the tire is spinning that fast, the tube inside of it is also spinning really fast. And then when you press on the brake pedal, like I did, the tube just kind of smashes itself into the valve stem. And when I took this bike, or sorry, when I took the tire to get repaired, they looked inside of it and it was ripped right at the valve stem, meaning like the spinning force basically pushed all its power right into the valve stem, and that's where the hole was made. So that's where the leak came from. So yeah, it's cool for videos, but it's not good in the real world. Don't be spinning your bike tire this fast, and you will save yourself from buying a whole new tube.
So went ahead and put some new duct tape on it because the batteries were a little bit loose. So now this is like one with the frame. It's very very secure now. So yeah, let's do a quick overview of the whole bike. Okay, so first off, we have the thumb throttle here, the key switch. All right, that's on, off. We have a flashlight mount for when I ride at night. Got the phone holder, all right, adjustable. These go in and out. I got this USB charger. So I got the USB cable here, Type C for the phone. The thing is, I just have to connect this wire for the USB charger. Where is it at? It's right here. Alright, I just gotta connect that to the battery terminal here. So I'm just waiting for my new solder gun to come in for me to do that, because I just broke my other one. So yeah, that's still in progress. Canadian Tire helmet, pretty nice, and then some gloves. Shitty bike lock, gotta upgrade that. But the thing we care about is the rest of the bike. So we have the flat cells, the pouch cells from battery hookup. We have one pack here and then one pack this way, so 2 packs, and it is a 20S 2P configuration, so 20 cells in series and 2 in parallel. So there's like 2 cells in parallel like this and then like that. And this is the battery management system app. So we do need charging, because right now we are at, let's see if it focus, 71 volts. And if we check the state of charge, all the batteries are like basically 3/4 drained, or sorry, 3/4 full. So we can charge that soon. So the rest of the bike, we have our Cyclone drive kit. So this is supposed to be an 18,000 watt motor, so 18 kilowatts. It came with this pedal crank with the ratcheting feature, so you can pedal and run the motor at the same time. This I had to add the chain tensioner here. The one they provided did not hold up to the speed. So that's that one. Right. So this thing is very crappy here. It wobbles a lot. So as you're pedaling, this pedal crank will wobble like left and right a little bit. So it still works with the chain setup that I have here, but yeah, it's just a little iffy. The next thing was the controller. So this controller came with no marking at all. It's still pretty warm. I just ran it for like 20 minutes. This does get hot quick, and like after an hour of running this, it will shut down because it just overheats. But yeah, the most I ever got out of this was like 77 amps. It's supposed to be 150 amps, but all I got was 77. So the whole system is like roughly 6 kilowatts of power. It's supposed to be 18 kilowatts, but it's like whatever. Yeah, just kind of false advertising from a Cyclone motor, but it's like to be expected from overseas suppliers, right? So anyways, the original cassette, the 9-speed cassette, just completely failed. It's too much power for it. So I went with this single cog setup, and with this chain tensioner, and all the links for all these products will be down below in the description. So these two were from Amazon. This is very good. Like, this metal here is a lot thicker than the normal cassette metal, so it can handle the power and the torque. So the chain is pretty tight, and the best part is it perfectly aligns right to the motor drive shaft. Oh yeah, that's the other thing. The shaft here with the sprocket, this actually broke the original from Cyclone. It just fell apart when I was like driving it, so it was very unsafe. I got another replacement from sickbikeparts.com, and that'll be down below. Yeah, so overall, the bike is complete. I just have to add the USB charging when I get my solder gun. And yeah, you can see right there, 18,000 watts, which is not true, but yeah. The only thing is, I am replacing the kickstands. I bought a kickstand from Bicycle World. It's just it takes time to ship in because it's on back order. This one is completely junk. It cannot handle the weight. It just bends. This one handles most of the weight, but it's very like thin and it's falling apart. Basically, it's getting pretty weak. So I do got to replace that. But yeah, overall, that's the whole bike. It's finally together, looking good. And yeah, it's a lot of fun. So let's go charge it now. Okay, so I'll show you how I charge it here. So there's only one main cable to the battery, right? Battery output's here. and I just connect it to the controller when I want to drive. And then when I want to charge it, this cable comes from the battery charger, and it goes directly to the battery plug there. So let me show you that here. You connect these. Okay, so that's in. Alright, so it's connected. So now the charger starts charging automatically. Alright, it shows 12 amps. And this is the adjustable current. Like, you can charge it slow if you want, like 1 amp, 2 amp, all the way to the max 12. So then if we look at the battery management system app, it's going to show us right there that we're taking 9.7 amps right now of charging. Alright. Then if you go look at the cells, you'll see that now they're charging. So yeah, it's pretty sweet. You also got the temperature. The range estimator is like completely off. I think you have to do some calibrations for that to actually work. But yeah, the rest is good. Like the 72 volts it's at right now. And then, oops, focus. The cells are varying from 3.62 to 3.67 right now. So yeah, pretty sweet. Alright, so I think that concludes this e-bike series. So yeah, there it is. Sweet. Alright guys, take care.